So you want to hear about the story of nicotine and the chemical hunt for its structure? Well, you're in luck. I just cut those pages from my endocannabinoid graphic novel based on Moby Dick, but I can share them with you here now. Because before we can understand the hunt for that smooth lipid THC, we must turn to America's other favorite smokable, tobacco. Because, despite all of tobacco's ills, every adult and every culture deserves the right to pick their own poison. The last carved words of Sir Walter Raleigh reminds us of this universal truth. At the end of that unlucky life, and the often unpleasant circumstances of the famed explorer, just before his final words ordering the executioner holding the axe to strike man, strike, Raleigh had left in his jail cell his tobacco pouch, engraved with the phrase, Cum mus fui in leo miserio tempore, which means, it was my companion at that most miserable time. The planters of tobacco had one perk over most other crop farmers. Since the leaves acted as a powerful insecticide, during the several stages of back-breaking harvest, which included, from the topping of the pink flowers, which are removed by hand, the serial primings, which is harvesting the leaves in 3 separate layers, and the hanging of the heavy, bulky bundles and the sticky dark sap that formed a dirt-attracting gum, fiendishly difficult to remove once hardened, and then on to the final curing in smoky barns before the grinding and rolling of the leaves into tight little coffin nails. No annoying bugs would bother them. The insects steered away because they found tobacco's active ingredient to be baneful and noxious. But among the farmers and processors, it wasn't until the 1970s that doctors serving in the more poverty-stricken pockets of the world where tobacco tended to be harvested described a condition they labeled green tobacco sickness. Only recently did the cause of this disease plaguing those working this plant come to be known as a nicotine overdose. Because scientists were looking what made this plant of the New World so damn attractive. Because each plant that's gotten some Homo sapien tribe high for hundreds or thousands of years, when finally placed beneath the microscope of modern chemistry, often serve to reveal our own unplumbed brain, and the many unknown molecular creatures still slithering there just out of sight. The story of nicotine well illustrates the many coils of knowledge a chemist must cross before a chemical can be rightly reported as known and characterized. Our serpentine journey begins in 1828 when the German chemists Posselt and Riemann isolated from tobacco the alkaloid now known as nicotine. They considered it a poison. Indeed, it remained a major insecticide for almost 50 years after World War II. But isolation is only the first step. Just because you caught a snake in a box, it doesn't mean that you know what it looks like. In 1843, Melsens chopped up the molecule, weighed its elements, and thus found the chemical formula be 10 carbons, 14 hydrogens, and 2 nitrogens. Another 50 years elapsed before Pinner and Wolfenstein achieved the next rung of chemical realization, the structure. With a palette of chemical tricks to illuminate the never-visible molecule, they puzzled out how Melsens' pile of elements fit together so snugly. In 1904, Pichet and Rochny finally achieved the chemical holy grail, synthesis of the molecule from scratch. As it's said by car mechanics, chemists, and Dick Feynman, if you can't piece together something from parts, you don't really get it. The remarkable synthesis here mapped showcases a complicated series of steps necessary and sufficient to yield precisely a molecule of nicotine. But this method pales against the efficiency witnessed in the natural biosynthesis pathway used by the Nicotiana rustica and tobacco plants. To this day, a route of creation still mysterious in many of its machinations. When the phytochemists peering into the plant first saw nicotine, it took them a few decades to realize how much it resembled one of our own earliest neurotransmitters, acetylcholine, an electric eel charging through the brain's ecosystem, and thus sparking the great neuronal debate of the early 20th century, soup versus spark. If you dug this, comment for part 2, and we can get into soup versus spark, the war over the neuron doctrine, and how all of this plays into acetylcholine.